Sales Director based out of New York. So on behalf of the Google Cloud family, I would like to thank all of you for joining us today and spending this hour with all of us. So I hope you, your family, as well as your loved one are doing well during this challenging period. This Lunch and Learn is part of the weekly Tech Talk series, and our goal is to spend this hour with you and serve our customer better. So previously, we covered topics such as business continuity, SRE, DevOps, advanced Kubernetes, and I invite you to join us on June 3rd to discuss BigQuery. I encourage you to sign up right now in the live chat box, where as soon as you sign up, we'll be able to send you the presentation after today's talk to ask you for feedback. We value the feedback and we learn from you. So please do not hesitate to share any topics you would like us to uncover during the next sessions. So after today's session, you will have the opportunity to discuss questions. So feel free also to add your question on YouTube live chat box. So without waiting, I would love to introduce you to Gabriela Ferrara. Gabi is a developer advocate and usually works with database, but loves solving problems with modern technologies such as serverless. So during today's session, Gabi will be talking about the best practices for serverless applications on Google Cloud. So without waiting, I wanted to welcome you, Gabi. You have the floor. Thank you.
Thank you, Ingrid. Today, you can call me all Gabi. Gabriela, it's usually when I'm in trouble. And I'll be presenting here. Let me share my screen. Today, we're going to be talking about serverless. And I used to joke, my director used to joke with me that everybody has their major and their minors, and serverless is my minor. And today, the serverless is to talk about like use cases that we usually have and what we can do about it and how to solve problems that you may be having. First of all, let's work with two definitions first. What it is serverless and what it is stateless. So serverless, it's a paradigm, let's say, that allows you to focus on code, not worry about infrastructure, allows you to have all this scaling, like scaling from a small number to a higher number or even to zero, and you pay what you use. That's one of the main characteristics of that. Stateless means those applications don't store data and doesn't have any state to be saved. Like if you want to process transactions of payments, then you need to save on a database. That wouldn't be stateless, but you still can do a stateless code that interfaces with a stateful one. And there's no persistent storage. So once you try to do an image resizing, for instance, you need to have a way to save that outside of the function or the computing resource you're using at the time. But let's talk about servers first. Is serverless the new shared hosting? I ask that because many of the resources you see, even in compute engine, if you launch a virtual machine, actually is a shared resource. It's not like the old days where you had like that panel and you had to upload your files via FTP and had to manage your own users and that kind of stuff to manage a physical server, but it was shared with other people. So what is the difference between now and then? Well, now with the advent of virtual machines and Docker and other things like Kubernetes, you can have like multi-tenancy on shared hardware with more security and with privacy too. So it is a kind of share hosting, but it's not at the same time. You can have dedicated resources if you want to, but there is an advantage to this. It works on my machine, saying that we always say when like something is broken, it's kind of not an excuse anymore. You can actually put it on another machine and work on the same way. Like if you're using Ansible to build your images, or you're working with Terraform, or working with Docker, or any other containerization technology, you can reproduce your dev environment, your staging environment, all those resources as the same as you have in production. And that's a good way, because then you know what you expect. I'm from the time where servers had names. Usually people thought it was a good idea to put in names like Zeus, Thor, Odin, like the gods, Greek gods, and Nordic gods. If you had to authenticate it to the server, you had to ask a sysadmin to give you a certificate or a username and password. I don't know how many of you have worked with Node.js or any JavaScript modern framework. Imagine having to upload all those dependencies using FTP. And that means FTP, it's one file at a time, and it may not work. So with the advent of technology now, you can use stuff like Git and take advantage of the fact that when you package your code, you're using a single compressed, not tarball, because it's not a tar. In the case of Git, they use zip. But you are not having to use, for instance, SVN or CVS anymore. And at the time, there was almost zero automation. For those who don't know, SVN and CVS, they are the old versions of predecessors of Git, Mercurial, and any type of code versioning that we had before. The modern approach is very better. Machines are commodity. You don't have to worry about how many servers you're going to spend for this or that. You can use continuous integration and continuous delivery. In this case, like you have Cloud Build, you have Travis CI, you have Circle CI, you have a lot of tools out there that you can use. Automation tools like Chef, Terraform, Puppet. And it makes all your job, that's all those bash scripts that you used to write, be easy to manage your resources and be able to scale horizontally. Don't forget the keywords right now that people are talking about. Containers, Kubernetes, Istio, Service Mesh, Knative, and in my opinion now, Cloud Run too. It's a new keyword that people are learning about Google Cloud. So why this is all useful? There is this new trend in the industry, which is not that new, about microservices. So when you think of serverless, the first thing people think about is creating different services to attend to different needs because of the single responsibility principle. So microservices could answer that question and solve your problems because they allow small services, like I just want to resize an image. You can create a cloud function for that. You can use different languages and stacks, like, the legacy application is in Java. We are migrating to Kotlin. I can run a Cloud Run container just for doing this transformation of image or data to go to a pipeline, for instance. It has, in a good practice, it has an independent storage, like microservices should not be reading from the main database directly, accessing it, but they can have storage linked to their own existence, and they're fault tolerant. So if the service on that container stops working, another container just spans in and starts doing what it was stopped before. But then you need to worry about queues and retries and have a lot of monitoring and observability tools linked to that. What I can link microservice to, it's usually the single responsibility of a business logic. Not the whole business logic, but just a single responsibility. Martin Fowler, it's one of the Java creators, says that it's a single application, has its own processes, and it's independently deployable by fully automated machinery. Again, microservices may not be for you if you don't have the physical people to help you deploy and create these kinds of pipelines. So that's what I see when I see microservices. You could think as the Earth as the monolith and all the satellites and garbage in space as the microservices. Because if you ever saw a graph of microservices, please Google it. I couldn't use the images that I found. It's something like that. It's a network of connected devices and nodes that talk to each other. And it's easy to become a mess too. Again, observability challenges. See, right now you can't see the Earth, right? But as much as more services, more satellites are sent to space, harder it will be to have a visibility of our own monolith, the Earth. But it's also going to be hard not to interfere in the communication between one and another. So how many times you wondered if a method call that you did on your preferred language, let's say print, you call print, and how many times that failed, the print state failed? Like 1 in a billion? It's a kind of pretty secure to say that that won't fail. But what about calls on the network? And that's one of the problems. So a transaction could have a 63% chance to do not occur if it takes more than 1 second. And even if microservices are successful, the request only success rate is of 98% of the time. So what happens is I saw a talk and I copied this. This is an example architecture of, this is before Kubernetes uses Apache Mesos. It's doing what Kubernetes and Istio does right now here. So all these errors are network calls just to reply to one request. So how can I help you with microservices and serverless? How can you keep the developer environment up to date to production infrastructure? And how do you break a monolith? So incremental changes usually are the best answer. For that, you could be using one of 3 things that we use here at Google Cloud for compute in this case. We have Google Cloud Functions, Google AppEngine, and Google Cloud Run. And if your application, you want to use functions, doesn't mean you need to use just functions. You can use just functions with Compute Engine, AppEngine, or even mesh all around and use all of them at the same time. Cloud Functions, it's focused again on the single responsibility purpose. You can map it to events and triggers, and it's available for Node.js if you're a JavaScript developer, Python, Go, and yesterday was just released the Java version for Java 11 beta. Use cases, microservices, as I mentioned. One use case that I see a lot of people using Cloud Functions for is that, let's say our user upload an image to your website and you want that cropped, automatically cropped. You just can't send an event, link that event to a bucket on Google Cloud Bucket, Cloud Storage, and say, once a file is uploaded to the bucket, trigger this function, and the function is going to get that image, process it, and save it the way you need it. IoT, because there's a lot of events, it's easier to do small processing with IoT and Cloud Functions. If you have ETLs, they're not that big because there is a limit of how long you can run a function. So instead of processing big batches, you can process a small batch of data or use for lightweight APIs. Again, lightweight. It's not to pull your whole application inside a function. Just because a function here, in the case of Python, comes with the micro framework Flask, doesn't mean you should put your whole Flask application on it. It's just to make it easier for you to develop. Again, the accepted platforms are, in case of JavaScript, uses Node.js, Python uses Flask, Java, and Go are by their own runtimes. This is an example of creating a cloud function. You can also create a cloud function using the gcloud command line. You can allocate up to, I think, 1 GB of memory for the cloud function. And those are all the options of triggers. As I mentioned before, Cloud PubSub is a queuing system that you can use to trigger events. Cloud Storage, for the example of the image, Firestore, and Firebase if you have any integration with it. By default, it doesn't come enable the authenticated invocations, which means it's not accessible for anywhere, everywhere in the web. And you can decide to edit the coding line or from cloud source repository or just send it to zip. This is an example of the editor of a Java 11 beta. I have here on the next slide an example of a code using cloud functions. But first, I have a demonstration. Let me just stop sharing for a second. I'll share again. Okay, here it is. Let me see where I stopped. Okay, this is the demonstration. This is, I got a tweet link. And what happened is I created a cloud function where it gets the ID of that tweet link, and it's gonna show the sentiment score on that message. In this case, it was neutral, the score, I think. Yeah. Sorry about that. Okay. You can access the URL using the QR code that's here on the top right, and you can edit the ID of the URL of the message here. So you can get any message that you use on Twitter to add in here, and it gives you the sentiment score. So that's just an example of classifying sentiments using Google Cloud Functions. Another example, this example itself is written in Python, and I created two auxiliaries functions, get tweet, that is going to call the tweet API and get a message, and the get sentiment that's going to call the Google Cloud AI API and get me what it is, that message. This code has like, I forgot to put their line numbers, but like it must not have more than 12 lines of code. So it's perfect size to be inside a Cloud function. And that's, once you put it inside a Cloud function, you put it on this port here, and you just say which function you want to execute. In this case, I want to execute classify. So I'm going to use classify when I call that Cloud function. Now, if you want to deploy something bigger, there is Google AppEngine. You could put the whole e-commerce platform inside AppEngine, and it has main cache together for you to use. It manages your SSL certificates. You can choose between 6 popular platforms to deploy your applications. And honestly, it scales a lot. Completely managed. For me, it's the best service that we have that most people don't talk about. And the reason is, it's people are used to VMs already or Kubernetes, but they forget about AppEngine, that they can solve their problems just using AppEngine. So AppEngine works on 2 concepts: services and versions. You can create a service inside of the same AppEngine project. You can create different versions and serve them through different services. Use cases. So a service could be, for instance, I have a develop environment. I have a production environment. And those services live independently inside the AppEngine. I can show you this here. So this AppEngine here has services. It has 2 services, default and version 2. And each service, it's going to have their own versions. So default is in here. It has v2, and it's going to have another version here too. You can split the traffic between them if you want to. I want to send specific traffic for an IP address, a cookie, or randomly. Or you can even say, we receive a percentage of the traffic if you have different versions of it. Why is this cool? Well, you can do A/B testing with this. You can do A/B testing for this. And for that, it's the same demo. It's the same code. It does the same thing, but deploy on AppEngine. So let me get it. And let's see what it's going to show me. See, that's again the Twitter that I have next Wednesday. Join me to talk about serverless. And it shows the magnitude, score, and the type of sentiment. This is running here on AppEngine version default. You can see specific. But if you want to see the version 2, I'm going to change this. I'm going to leave it without it. See version 1 and version 2. Hello World version 2. They're different applications, but they are using the same bucket, let's say, organizational bucket for you to solve your problems. So that's what is cool about an AppEngine. You can have services, you can have versions, and not have to worry about the infrastructure about those. This is an example code of Sinatra. in Ruby. You have here application. I'm just saying here in the beginning, that's a JSON. And the Twitter client that I'm going to get a message on that ID that you passed to me. And I'll get the analyzing sentiment on that client. And I'm just putting a version to know which one I'm using and reply to that page with the result. That's what it generated, that JSON that you saw before. That was this code. It's small enough that could be inside a function, but at this case, imagine there was a bigger thing. So like a whole CMS website, you could have different versions and services for it. So you have your code. Now, Gabby, how do I put this code on AppEngine? So you need one file called app.yaml, and you run two commands, which is gcloud app create, and the app.yaml, you say the runtime, the entry point, which it is the command that's gonna make the server run, and which service is. In this case, if you don't want to say which services, it's gonna be default to default, but like you could put production, testing, QA, whatever name you want, and then you do gcloud app deploy. You can deploy multiple services. As I showed you, mine, I had two services, and one was default, and the other one in this case is dev, and have those running separately. They could be completely different codes, but the idea is to be able to maybe load balance different codes, do A/B testing and that kind of stuff, or to keep similar versions of the software accessible for you throughout the compute resources. And Cloud Run, I should have removed it. It's not on beta anymore. It's GA. You can run it fully managed or on Anthos. That means you can run on your Kubernetes cluster with your own the resources you have available. You can run Cloud Run. It's container-based and revision-based. So it based itself on immutability. It's once you edit the deployment, it creates a new one, and you still have access to the older deployment, but you cannot just change it and update it. It always creates a new revision. You can scale to 0 or up the amount of the requests, where the requests is the instance times maximums of instance. That math actually goes up to like 80 requests, I think, concurrent, and times the amount of maximum instances you put up on the configuration. It has up to 2 gigabytes of memory per revision, and those limits change if you're using Anthos on your GKE cluster. So Cloud Run is basically anything you want to run, you can run on Cloud Run. Gabby, I have a COBOL code that I wrote in 1995, and I want to run this on Docker. And there is a binary. How do I do it? If you can put it on a container, you can run on Cloud Run. If you figure out the port of running COBOL in a container, you can run on Cloud Run. There is the only need that you need to assure is to have an entry point defined on your Docker file, so you can actually access what you just deployed. So when you create a service, you select the container image, select which region and what type of deployment it's going to be, and the service settings. Again, like Cloud Function can also have unauthenticated invocations or require authentication based on your IAM configurations. This is the same code again, but this time running on Cloud Run. the serverless community usually deals with one problem when compared to Kubernetes, which are cold starts. And sometimes you may notice that it takes a while for something to run. That's because it did scale out to 0 and it needs to redeploy the images so it can actually run your code again. So you need to think, what is going to be my application and if I can tolerate that kind of latency. So here is the same thing. Oh, wait a moment. Technical difficulties. Oh, don't know why it was forbidden. Oh, I know why. It's serving an old function, old version. This is the same code again, version 1.1. This is actually an older Twitter that I had when I was traveling to this talk on another conference. Let me get the same one. And if you put in here, and it got as neutral again. It's the same application. And when you look here on the services on Cloud Run, which it is Sentiment Analyzer, it's going to show you the revisions that are running. And yes, I need to delete this now. And how many, you can split the traffic to, but like the AppEngine, and I'll look at your metrics here and YAML files. So what Cloud Run is basically Kubernetes with Knative and with the ability to scale down to 0. Now, Kubernetes, Cloud Run on Anthos does not scale to 0 because some nodes still needs to run. And if you deploy a Ruby app, which it is our case, what do you only need for Cloud Run to have that app running? It's a Docker file saying, hey, what is the base of this Docker file? Which port I'm going to be using? This is just to say that the config file for dependencies is frozen. Where's the source? Install the dependencies and just run the service. That's what you actually, those steps that you're doing here are the same steps that you do once you run this application on the computer, on your computer. To deploy a container, you can use Google Cloud Shell, which is amazing. You don't have to have Docker on your computer to deploy it. You can actually use the cloud to do that for you. So you just say that you're using Google Cloud Build, that you're going to submit an image, and that's your project ID name and the app name. In this case, is AutoML Sentiment Analyzer. And if you look at my images, you're going to see this image there. Once I have the image, I just say to the Cloud Run service to deploy my AutoML Sentiment Analyzer on a managed platform. So how do you choose? This is a bit big. You can have this access later. But basically, if you're working with stateless HTTP, should be using either Cloud Run or using AppEngine. So the only problem with Cloud Functions, specifically in HTTP, it's that they don't accept custom domains. You need to use their own. And there's something with WebSockets too. I'm going to show you. But like if you have a language, like I know Rust is very popular now, and you want to do something with Rust, but there's no Cloud Functions with Rust. Well, you have Cloud Run. You could actually create your own functions with of Rust using Cloud Run. And then if it's a full-blown application, you can use AppEngine instead of Kubernetes, for instance. So this is just a comparison. I'll make this available later. what it is available for each platform and the languages that they use. You see the AppEngine supports more languages than Cloud Functions do. And there is a beta now, I just learned today, of HTTP2 and gRPC for Cloud Run. So it may be available in the future. Request timeout for now on Cloud Run is 15 minutes, but there is an offer to change it to an hour. And the other ones are 1 minute and 9 minute. AppEngine, usually standard languages has a 1 minute timeout, and Cloud Functions has 9 minutes. Concurrency requests. Each time you call a function, it creates a new instance. So one instance, one request per function. And AppEngine and Cloud Run for Anthos, it's usually 80 requests per instance. So those are the major difference between them. You can mix and match, have a stateless, serverless application with their state saved in the data on a single or DBMS database. One example is this one. Let me click here. Oops. So it's also a Cloud Run service. So let me go back to my Cloud Run. It's a quizzes one that I did, and it's the most polemic thing of the world. What do you prefer, tabs or spaces? This is saved on a database, the votes. I'm going to vote for spaces because it is my favorite. I'm going to put the URL back here. So as I was saying, you can mix and match, have different services like Cloud Functions with AppEngine and Cloud Run, and even Kubernetes using your Cloud SQL Cloud SQL or managed database. And if you want to have a BI integration with BigQuery, is also possible. So don't try to put everything on the same basket. Like, oh, I'm gonna do my whole API just using Cloud Functions, because it's hard to read in the end, keep track of. But you could do something using Cloud Run. In fact, I do have a personal project I'll share on Twitter later that I use Cloud Run completely for the backend API, and I use CDN for the front end. So let me see how it is right now, the votes. Did you vote? Just one person vote. Come on, people. Spaces. Well, in the end, to summarize, this is one of the PMs for Cloud Run. He says Cloud Functions is do one thing, AppEngine do many things, and Cloud Run, you can do anything. So that's what I have for today. Thank you. And I'll be looking at questions now.
Wonderful. Thank you very much for the great presentation. So we do have a lot of chat and question, and since we had an amazing group of customers already engaging, so I'll let you go through the list on the right corner. Thank you.
Okay, I'll present again so I can see the. No, I won't present. Do I need to present again, or just?
No, you don't. You just go to the YouTube live, and it's wonderful.
So
thank you.
Let me see. Yeah, you're welcome.
Yeah, just leave the presenter mode, and we can start.
Ansible undocked. Yeah, Microsoft Source Safe was complicated. how long can a function run in Cloud Functions? The 60 minutes time out in beta, someone already replied. 60 minutes is short for my apps anyway. Games never end and music can play for hours. Visualer, maybe Cloud Functions is not the right tool. But you may be looking maybe at Cloud Run, I think it has, for 15 minutes. But you should look at that as a processing, a job for you, not something to be connecting, serving that all the time. It's just small tasks. Yeah, Juliano said that. And yeah, I'm reading and he already replied whatever I said. I want to use Kubernetes. What are the advantages or disadvantages of using AppEngine and portability? So Kubernetes is really good for you if you're using stateless applications. Like, let's say you have running WordPress, and WordPress stores their dynamic files they download from plugins inside the application folder, and you would have that problem with AppEngine too. I would run those kind of applications that's more stateful based inside of Cloud Run. However, the code store for Cloud Run is bigger than AppEngine, and Kubernetes, the code store is really low compared to both of them in the end. However, the portability port, I don't know if I'm getting what you mean, what you want from it. Like you want to run on a container too, and then run an AppEngine. I need to understand a bit better that. The TPUs with Anthos, as I'm not sure right now because they changed that, but I can ask them I can verify that answer and post here on the YouTube comments, Eric. I'm not very familiar with the TPU usage, unfortunately. And Juliano is clarifying the HTTP2 is available on AppEngine. Is there any more questions?
No, this is what we have for today. Just asking our customer if there is any other question before we wrap up.
Okay.
They know. Just looking at the window now. All right. So thank you. Thank you, Gabby, for your time, for joining us today, for presenting to our customers. And I want to also thank the customer for their interactivity, their interaction with us, as well as great questions. So I just want to remind all of us and all of you to join us for the next Lunch and Learn next week with BigQuery. I will send to you as soon as you register the registration form. Don't hesitate to contact your Google Cloud sales team. We are here to help you, and we are here to serve you. So the session of today and all the previous presentation are posted on the Google Cloud Forum. So you can watch them at any time. So subscribe. Don't hesitate also to share the word with your colleagues and within your organization. And we are really happy to be able to welcome you every single Wednesday at noon for Google Cloud Lunch and Learn. So thank you for joining us today. And I wish you a safe and a great end of week. Talk to you very soon. Bye-bye.